Section 7.8 is called Solving Problems Using Quadratic Models. We're going to go through a whole bunch of different types of questions, and the key to this section is being able to figure out what form you're working with and how you are going to find the answer. What answer are you looking for? Are you looking for the x-intercepts? Are you looking for the vertex? You have to be able to decipher that. So the first bullet point here says, an equation, a graph, or a table of values can represent a relation. Use the form that's most helpful for the context of the problem. Even though it's a word problem, sometimes sketching a quick graph and drawing in the information that you know will help you understand it more fully. Bullet 2 says you can use vertex form or standard form to create an algebraic model. Use the form that's most helpful. And the very last important point is very important. When you solve a quadratic equation, check that your answer actually makes sense. Remember that sometimes for these questions we're going to get two answers. That doesn't always mean that both are potential answers. One might not make any sense in the context of the problem. Dive right in and do an example here. So example 1, you're an astronaut on the moon. You hit a golf ball with your golf club. The height of the ball, h of t in meters over time, t in seconds, can be modeled by this function. So what that means is height is on our y-axis and time is on our x-axis. And if we hit a golf ball, it's going to create, oh boy, that's a bad line. Let me try that again. It's going to create a parabolic shape. You'll have to forgive my drawings here. My stylus wants to do a squiggly line. We want to know the maximum height of the ball. Well, think about where on this line are you going to find the maximum height of the ball? Think about that. Logically, that's going to happen at the vertex, right? So we have to find the point of that vertex. Now, we could do that two ways. We can solve our equation and find the x-intercepts and then take the average of the two to find our axis of symmetry, and then use our axis of symmetry point to find the y value, or we could just use our graphing calculators. So I'm gonna try and add a video here of our graphing calculator. Okay, so if we are using our graphing calculators, we're going to go into, sorry, I'll try and keep that in the middle of the screen. We're going to go into y equals, clear whatever happens to be in there, and we're going to type in our equation. So we're typing in negative 0.81x squared plus 5x, and then we're going to hit graph. Now, if your screen does not look like that, remember that you want to hit zoom and then option number 6 for square, and it's going to give you that. Now, we know that we want to know the maximum height of the ball, so we want to know the coordinates of our vertex point. The easiest way to do that is to use your arrow buttons to go over to where the vertex is. So notice how I'm just moving that cursor up there. Now we want to get as accurate as possible. So I'm going to zoom and I'm going to zoom in. So option number 2. And then you have to hit the enter button to zoom in on that space where you had your cursor. So it brings us in closer. Now, I don't know if you can notice really well here, but see how my cursor is not really blinking at the exact vertex point? I'm going to move it over just a little bit and make sure that it's exactly at the vertex. Now, you'll find that our x value here is 3.08 and our y value is 7.7. In terms of this problem, remember x is time and y is height. This means after 3.1 seconds approximately, the ball is 7.7 meters high. So the coordinates of this vertex point right here is 3.1 and 7.7. which means the ball is 7.7 meters high at its highest point. All right, so that is solving a question using our graphing calculators. Let's look at the next example. Okay, so this question's a little bit different because this time we're not given an equation to work with. So it says Patricia drives from, let's try that again. Patricia dives from a platform that is 10 meters high. She reaches her maximum height of 0.5 meters above the platform. That's going to be important information. After 0.32 seconds. How long will Patricia take to reach the water? So, like I said before, sometimes drawing a parabola picture of this is helpful. Now she's starting 10 meters above the water on her platform. So if you think about that, that's at a point of 0, 10. This is time in seconds. She hasn't jumped yet, so that's why time is 0. And this is the height of the platform. Now, she jumps and reaches her maximum height of 0.5 meters above the platform before she dives and hits the water. So this point right there, we know the coordinates of because she's a half a meter above the platform. Well, the platform is 10 meters high, so she's at a point of 10.5 meters. That's our Y number. And she's at that point after 0.32 seconds. We want to know how long it's going to take her to hit the water. We want to know that X value right there. In order to be able to do that, we have to have an equation. So we have to think about what form of an equation we can write. We know what information here. We know the vertex. So we're going to use vertex form. Y equals A times X minus H squared plus K. Now remember, I've said this over and over and over again, when you're writing an equation, the first thing you have to find is A. So I know an X and a Y point that are on this parabola other than the vertex, and it's that point right there. So Y is going to be 0. A is what we're looking for. Oh, sorry, Y is not 0. X is 0. Y is 10. X is 0. H, remember our vertex point is always H, okay? So H in this case is 0.32 squared, and K is 10.5. So to start solving this, I'm going to subtract 10.5 from both sides. And we're going to get negative 0.5 equals A times negative 0.32 squared. So calculate what negative 0.32 squared is, and you're going to get 0.12. Sorry, 0.1024. And we're going to divide both sides by that number to cancel them out there. And A is going to equal negative 4.88. So now that we found A, we put that into our equation. Y equals negative 4.88 times X minus 0.32 squared plus 10.5. We want to know the x-intercepts of that equation. So you can do a couple of things. Actually, not really in this case. I would suggest, again, using your graphing calculator. So let me grab my graphing calculator here. Okay, so you're going to go into y equals. You're going to clear whatever you have in there. and you're typing in the equation as it is written, as we just wrote it. So negative 4.88, open up a bracket, x minus 0.32, close that bracket, hit your squared button, plus 10.5, and then we're going to hit graph. Now, chances are your zoom is all messed up from the last question. You're just zoomed in on a really small part of the screen. So remember to hit zoom 6. Now, we only are concerned about our x-intercepts. Now you got to ask yourself, do we really care about the negative x-intercept? Remember, we're talking about time. So the answer to that is no. We want to find out what that x-intercept is. So remember how to do your zeros. So second function trace. We're looking for the zeros. If you're on an old calculator, that will say roots. And we want the left bound of that point right there. So I'm going to move my cursor. I don't even know where my cursor is. There it is. I'm going to move my cursor to somewhere above the x-axis, right there. I'm going to hit enter. I now want the right bound, so I'm going to go below, and I'm going to hit enter. And then I want it to guess, so I'm going to hit enter. And we get an x-intercept of 1.78. So that's how long, if we go back here, up to my diagram, this is how long it takes her to reach. That's that point right there. So x is going to equal 1.78 seconds. All right, that's the answer to the question. Let's have a look at example 3. Okay, example 3 says, the engineers who designed the Coal River Bridge on the Alaska Highway in BC used a supporting arch with twin metal arcs. The function that describes the arc is this equation function right here. So that represents the function of the arch. H of x is the height in meters of the arch above the ice at any distance, x in meters from one end of the bridge. Determine the distances between the bases of the arch and then determine the maximum height. So here's what this means. Here's our bridge. Here's the arch of the bridge that this is supporting. So here's your bridge. This is the arch of that bridge. We want to know the distance between the bases of the arch. So we want to know that to that. How far in x meters are those 2 points? And then we want to know the maximum height of the arch. So obviously the vertex point is going to be the maximum height of the bridge. So we got a couple of things to find here. You could use your graphing calculator if you want to find the x-intercepts. This equation is fairly simple to partially factor, simply because it has no constant at the end. All right, so we could partially factor this. Let me write this back out. Hopefully I can fit it here. Negative 0.005061 x squared plus 0.499015x. So if I partially factor that, I can take out an x, and I'm left with negative 0.005061x plus 0.499015. All I did was factor out an x. Remember, after we partially factor, we set each factor equal to 0. So the first factor is x. That's easy. And the other one, negative 0.005061x plus 0.499015 equals 0. So I'm trying to isolate x in this case. So I'm going to subtract this number from both sides. which means I'm going to end up with negative 0.005061x equals negative 0.499015. And then to isolate x, we divide both sides by negative 0.005061. I'm going to do that same thing over here. And x is going to equal, so you punch that in on your calculator, negative 0.499015 divided by that number, and you will get 98.6. So that one has a value of x equals 0, and that point right there has a value of x equals 98.6. So they are 98.6 meters apart. Now, if we want to know this vertex point right here, we know that the axis of symmetry is going to be the average of our two x-intercepts. So 0 plus 98.6 divided by 2, x will equal 49.3. And then to find the matching y value, hopefully this is becoming familiar to you. You're going to put that x value into your equation, times 49.3 squared plus 0.499015 times 49.3, and you're going to get an answer of 12.3 meters. So the maximum height of the arch is 12.3 meters. All right, next question. Let's see, consecutive integers question. You're going to have to do one of these for sure on your test. So hopefully you will be able to figure this out. Now, the question here says determine 3 consecutive odd integers. So you have to understand this word consecutive. That means in a row. So 3 consecutive odd integers, for example, would be 1, 3, and 5. Those are odd numbers that all come one right after the other. Or -7, -5, -3. Those would be 3 consecutive odd integers. Now we're trying to find 3 consecutive that fit this criteria. So we have to actually use a variable to represent 3 consecutive odd integers. So if you first think about how to write an odd integer, we know that odd integers always come right after or right before a even number. So think about how to write an even number as a variable, or as an unknown, I guess. Well, we know that if we multiply any number by 2, it's going to end up being even. So if I multiply 3 by 2, I'm going to get 6. That's an even number. If I multiply 7 by 2, I'm going to get 14. That's an even number. And after every even number comes an odd number. So if I add one more to that, I'm going to get an odd number. So there's my first odd number. My second odd number will be 2 bigger than this number. So I'm going to add 3 this time. And my third odd number will be 2 more than that, which means I'm going to add 5 to my original. Now, I have to put that into this criteria. So the square of the largest integer is, that word is means equals. So I'm going to take the square of the biggest number. This is my biggest number. I'm going to square it. It is 33 less than. So I'm going to subtract 33 from the sum of the squares of the 2 smaller numbers. Sum means adding. Squares means I'm going to square them. So 2x plus 1 squared plus 2x plus 3 squared. And there's my equation. Now I got to figure it out. Now for this question, there is a whole lot of FOIL that has to happen. So 2x plus 5 squared means 2x plus 5 plus 2x plus 5. 2x plus 1 squared means 2x plus 1 times 2x plus 1. And this means 2x plus 3 times 2x plus 3. And then we got a minus 33 kicking around at the end. Now, I want you to pause this video and try and FOIL and simplify all of those, and then come back and check your work with my work. So this is going to end up being 4x squared plus 20x plus 25. And over here, we're going to get 4x squared plus 4x plus 1 plus 4x squared plus 12x plus 9 minus 33. So then I'm going to combine some like terms on this side. So I'm going to get 8x squared plus 16x minus 23. And over here I've got 4x squared plus 20x plus 25. And now remember, to be able to solve an equation, you have to be able to collect like terms and have it equal to 0. So I'm going to subtract 4x squared. I'm going to subtract 20x. And I'm going to subtract 25. And I'm going to get 0 equals 4x squared minus 4x minus 48. That is the simplified version of our equation. And now, now we can solve that equation. I'm going to add a little video here. I'm going to use my calculator just because I find it a little bit faster, and we did a lot of math there. So I'm going to go into y equals. Sorry, let me show this video here. Okay, I'm into y equals, and I'm going to hit clear, and I'm going to type in 4x squared minus 4x minus 48, and then I'm going to graph it. Now, I want to know my two x-intercepts, so I'm going to go second function trace for the zeros option, or roots. And I want the left bound. I'm going to go over here and do this one first. So my left bound has to, excuse me, come up above there. I'm going to hit enter. I need a right bound, so I'm going to go below, and I'm going to hit enter, and it's going to guess. And I get an x-intercept of -3. Now, let's go solve the other one. So second function trace, I want the zeros. Left bound, so I have to go down around that vertex. Just keep hitting over until you see your y values start to come smaller again. I know I'm getting close now. There it is. So enter for left bound, go up for right bound, and guess. And we get an x value of 4. Now, here's the thing. Grade Foundations 20. If you go back up to our original statement here, we've got numbers of 2x plus 1, 2x plus 3, and 2x plus 5. So if we take our answers here, let me just write that down. 2x plus 1, 2x plus 3, and 2x plus 5. If you take our answer of x equals -3 and put it into each one of those, you're going to get, so 2 times -3 is -6, plus 1 is a -5. Here you're going to get a -3 and a -1. So there is one option of 3 consecutive odd integers that would fit that criteria. Or the other one would be substituting 4 in. So here you're going to get 9, 11, and 13. So that would be another set. So we've got 2 answers here for this question. Okay, very last example. At noon, a sailboat leaves a harbor. Here's going to be our harbor on Vancouver Island and travels due west, so straight west at 10 kilometers an hour. 3 hours later, another sailboat goes due south at 15 kilometers per hour. At what time, to the nearest minute, are those 2 boats 40 kilometers apart? Now, because these are due west and south directions, we know that that's a 90-degree angle. So we're dealing with Pythagorean theorem here. The only thing is we need to make our equations. Now, how far did they go due west? Well, they were traveling at 10 kilometers per hour. So we're going to need an unknown here. I'm going to say h is our time. So he went 10 kilometers per means multiply, however long he traveled for. And this direction right here traveled at 15 kilometers per hour, but left 3 hours later. So he went 15 kilometers per hour minus that 3-hour head start that he gave him. Okay, so his total time that they're traveling minus the 3-hour head start multiplied by how fast he's going. So if we think Pythagorean theorem, a squared plus b squared equals c squared, we're going to have 10h squared plus 15 times h minus 3 squared equals 40 squared. And now we got to do the math on expanding that. So 10h squared, remember your exponent rules. This squared multiplies to everything, or it belongs to everything. So we're going to get 100h squared plus, I'm going to expand and distribute in here first. So I'm going to get 15h minus 45 squared equals 40 squared, which is 1600. Now I'm going to distribute the squared to everything, and I'm going to get 225h squared minus 1350h plus 2025 equals 1600. Sorry, just to verify. This 15h minus 45 squared, you're going to have to FOIL. Okay? And then I'm going to combine like terms. So h squareds are going to go together. We're going to get 325h squared minus 1350h plus, I'm going to subtract 1600 from both sides. So we're going to get plus 425 equals 0. Now, you can solve this either using your calculator, or you could try and factor it. It's not going to factor very nicely. You could use your quadratic function if you want. I'm going to go ahead and use my calculator. So, sorry, let me just add this video clip in here. All right, so hit your y equals, hit clear, type in your equation. So 325x squared minus 1350x plus 425, and then hit graph. Now, our window is way too small, so I'm going to change this to negative 500 and 500 and negative 500 and 500. Oh, and now I might have made it too big. Still not working. Alrighty, it might just not graph very nicely. So when in doubt, find another method. So I'm going to use my quadratic function instead. I want to get this decreased a little bit. So I'm going to look for a factor that I can factor out. That factor is 25 in this case. So I'm going to take out 25 and I'm left with 13h squared minus 54h plus 17 equals 0. And I'm going to use the quadratic function. So remember, your quadratic function is x equals minus b plus or minus the square root, b squared minus 4ac, all divided by 2a. So in this case, I'm looking at using this. So negative b is going to give me a positive 54 plus or minus the square root of negative 54 squared minus 4 times 13 times 17, all divided by 2 times 13. And punching that into your calculator, you should get 54 plus or minus the square root of 2032 divided by 26. So we're looking for approximate answers here. You're going to get an answer of x equals 3.8 or x equals 0.34. Now, remember that this is in hours right now, and you have to think about some common sense here. The second boat didn't leave until after 3 hours. So would it make sense for the boats to only have to travel 0.34 of an hour? No, because the second boat hasn't even left the harbor yet. Okay, so it makes more sense for the total time to be something bigger than 3 hours. Okay, so you have to change this to minutes essentially. So we're looking at 3 hours and however much 0.8 of an hour is. So 0.8 times 60 minutes in an hour gives you 48 minutes. So it takes 3 hours and 48 minutes after boat 1. Okay, that is it. Those are the questions I want you to try. You get to pick, and please come see me for some extra help if you are struggling with this.